हेलो स्टूडेंट्स, आज रोलिंग के काइनेमैटिक्स पे एक रिलेटिवली सिंपल क्वेश्चन करते हैं और रोलिंग मोशन के काइनेमैटिक्स के अपने कॉन्सेप्ट को एक बार फिर से रिवाइज कर लेते हैं। आइए देखते हैं आज का क्वेश्चन। अ डिस्क ऑफ रेडियस स्मॉल आर रोल्स यूनिफॉर्मली विदाउट स्लिपिंग अराउंड द इनसाइड ऑफ ए फिक्स्ड hoop of radius r. This is a fixed hoop. Hoop means ring. This is a ring of radius capital R and this is the disk of radius small r. So this disk is rolling without slipping inside this hoop. इस hoop के अंदर ये ring ऐसे ring के लिए track है, ऐसा समझ लो. This hoop is the track of the ring and the ring is rolling inside the hoop, inside the ring. If the time period of the disk's motion around the hoop is t, what is given? Time period of revolution. This disk takes time t to complete one revolution. What is the instantaneous speed of the point on the disk opposite to the point of contact? Now the question is asking if this is the point of contact, then what is the instantaneous speed of this point? The point that is directly opposite to point of contact. What is the speed of this point of the disk? That is the question. देख क्या रहे हो? फिर से क्वेश्चन समझ गए तो बेटा वीडियो पॉज करो और वीडियो पॉज करके खुद से ट्राई करो. बहुत ही सिंपल क्वेश्चन है, कर लोगे तुम लोग. मैं अपना सॉल्यूशन जारी रखता हूं. स्टूडेंट्स, दिस इज रियली सिंपल क्वेश्चन. इफ द टाइम पीरियड इज t, what is the angular speed? Angular speed. Let us consider the motion of this center of this disk. The center of the disk is going in a circle of radius r minus r. Am I right? R minus r. Now, what is the angular speed of this revolution? And the angular speed is nothing but 2 pi upon time period. So angular speed of revolution of center of the disk. Just disk के center को देखो, it is going in a circle of radius r minus r and it completes one revolution in time t. Therefore its angular speed is 2 pi by t radian per second. So what is the speed of center of this disk? फिर से जरा ध्यान से देखो. Forget about everything else. Just look at the motion of center of the disk. Center of the disk is going in a circle of radius r minus r and its angular speed is this much, omega, it is known. So what if a particle is going in a circle of radius r with angular speed omega, what is its speed? Omega r, isn't it? So v is nothing but omega into r. R is r minus r. What is omega? Omega is a known number. I'll substitute later. So if this omega is known, I know the speed of center of the disk. Now the question is pretty straightforward. If I have a rolling object and I know the speed, this must be spinning here also, isn't it? Then only it can roll without slipping. All of you know, I guess, if a round object is rolling without slipping, its center is moving at speed v, then the topmost point moves at speed 2v, isn't it? So if the center has a speed v, the topmost point has a speed 2v. This is our answer, 2v. Yes, 2v. V means omega into r minus r. So in place of omega you have to write this. So this becomes 4 pi by t omega r minus r. In case of pure rolling, in case of rolling without slipping, it is true that the topmost point has velocity 2v. If center has velocity v, the contact point has 0 velocity. This happens because actually this rigid body has got two kinds of motion. It is spinning about its center and the whole thing is translating as well. So to find the speed of any particular point in the body, we need to superimpose two effects: its velocity due to rotation and its velocity due to translation. They have to be added vectorially. So if the disk is just sliding, it's not rotating. If the whole thing is moving with velocity v like this, there is no rotation, then each and every point has velocity v. But if the disk is simply spinning, just spinning, forget about any translational motion, it is just spinning, then every point has velocity omega into r in tangential direction. So when a disk is rolling without slipping, we all know that v is equal to omega r. So, this omega r is nothing but v. Because of rotation, top point has velocity v. Because of translation, the top point has velocity v. Superimpose both of them and the top point has velocity 2v. So, 2v is our answer and v is nothing but omega into r minus r. Value of omega is given. So, this is a very simple question. I guess many of you must have solved it on your own. Goodbye. See you in the next video.